I'm going to keep teaching. So we already did 7.1, which was writing the equations. Now we're going to go into solving them. So if you can follow along in your book, I'm on chapter 7.2, solving equations using addition and subtraction. And I am going to start notes on page 302. So if you want to check that out in your book and get your notebook, we'll get started on notes right away. All right, so chapter 7.2 is solving equations using addition or subtraction. The first thing you need to know is what a solution is. So a solution of an equation is a value that makes an equation true. So you might see a direction that says find the solution or tell whether a certain number is a solution or not. So here's just an example. Solve. Here's the equation, x plus 3 equals 7. And tell whether x equals 3 is a solution. So what they want you to do is plug in 3 where x is, and then solve it, and see if you get the same answer on each side of the equation, or the equal sign, each side of the equal sign. So if we do that, I'm going to plug in 3 here. I'm going to plug in 3 for x. So then I have 3 plus 3 equals 7. Well, on this side, I get 3 plus 3 is 6, and 6 does not equal 7. So I would say no, that 3 is not a solution. If they said tell whether x equals 4 is a solution, I would plug in 4 for x. I would have 4 plus 3 on this side equals 7. I do get 7 on this side. 7 equals 7. So x equals 4 would be a solution to this equation. And that's just kind of a yes or no question. Okay, this is super important. Inverse operations. You're going to hear that next year in 7th grade a lot. So inverse operations are the opposite operation being used in an equation so you can undo the equation to find a solution. So what we're doing is we're going to unravel an equation, or we're going to undo it so we can break it down to figure out what the variable is. We want to solve for that variable, that letter. And we want to find a solution, something that's going to make it true. So lock that in your brain, inverse operations. It means the opposite. So if the equation has addition in it, we're actually going to use subtraction to solve it, and vice versa. If it has subtraction in it, we're going to use addition to solve it. Important to know. Fence method. You'll hear this next year as well. The fence is going to go through your equal sign. You must do the same thing on each side of the fence. So here is an equation. X minus 4 equals 5. This is my fence. Ooh. This is my fence. I draw it right through the equal sign. And I circle my variable. And then I look at the operation next to the variable. So in this case, I have x minus 4. I'm circling the variable x, and I'm going to do the opposite of minus 4, which would be adding 4. And I have to do that to each side of the fence, each side of the equal sign. These are going to go away because that's a positive and a negative 4. Those equal out to 0. And I'm just left with my x on this side. And then I go ahead and add on this side of the equal sign. So I have 5 plus 4 is going to give me 9. So I solved the equation and got x equals 9. That is my solution. I can check it by plugging 9 in for x. So I would have 9 minus 4 equals 5. I do get 5 on this side. That equals 5. So yes, that would be a solution. So this one, it's different. It's x plus 4 equals 5. Looks very similar. And for this one, I'm going to circle the variable x, and I'm going to look next to it to see that it's adding 4. So I want to do the opposite, the inverse operations. I want to do subtracting 4 on both sides of my fence. Again, here's my fence drawn right through that equal sign. This positive 4 and negative 4, they're going to go away. That's going to equal 0, and I'm going to be left with my x on this side. And then I'm going to do the math over here. I have 5 minus 4, which is 1, so my solution would be x equals 1. I can plug that 1 back in up here. 1 plus 4 equals 5. I do get 5 on this side, 5 on this side, so that would be a solution. You can pause the video if you need to finish up. Okay, so let's look at a couple of examples here. This just tells you you must show all your steps for inverse operations. Whatever you do to one side of the fence, you must do to the other side of the fence. So if you're subtracting 4 on one side, you have to subtract 4 on the other side of the fence. And you must show a check step for each problem. I know you're excited about that. So let's look at these. So the original equation here is k minus 9 equals 3. I've drawn my fence. I've circled my variable. I look next to the variable to see what operation is being used. It's subtracting 9. I want to do the opposite. I want to do inverse operations. So I want to add 9 to both sides of my fence. That's going to get rid of the 9 on this side. I'm left with my k. And then 9 plus 3 on this side would give me 12. So I'm saying that my solution is k equals 12. Now my check step just has me plugging in 12. I plug in 12 for k. So I have 12 minus 9 on this side equals 3. 12 minus 9 is 3. 3 does equal 3. That is a solution. And I've done it correctly. Let's look at this one. 25 plus g equals 47. Draw my fence down the equal sign. Circle my variable, look next to my variable to see what operation is being used. It says plus 25. So I want to subtract 25. I want to do the inverse operation, the opposite. I'm going to subtract 25 from both sides of my fence. These are going to go away. I have a positive and a negative 25. That leaves me with my g on this side. And then I have 47 minus 25. Do the math. You're going to get 22. So g equals 22. I can do my check step. Oh, sorry about that. Do my check step, 25 plus, plug in my 22 here, and I get 47 equals 47. So that is correct. Let's look at another one. Okay, number 3. Let me zoom in on that a little bit. So I have 15. The equal sign is over on this side now, and then r minus 6. I still want to draw that fence down the equal sign. I still want to circle my variable, and I'm working on the side of the variable. So I look next to my variable, I have minus 6. I want to do the opposite of that to solve. So I want to add 6 to each side. These are going to go away. I am left with my r on this side. R drops down. And then I have 15 plus 6, which gives me 21 on this side. So my solution would be r equals 21. I can do the check step on that one. Plug in 21 here. 21 minus 6 does give me 15. 15 is 15. So that would be a solution. Let's look at number 4. I have n plus 10 equals 26. Fence down the equal sign, circle my variable, look next to my variable, I have adding 10. I'm going to do the opposite, which is subtracting 10 from each side of my fence. These are going to go away, and I'm left with my n. And then I have 26 minus 10, which gives me 16. So n equals 16 for this one. Plug that 16 in up here. I have 16 plus 10 equals 26. And yes, that does give me the correct answer. And hopefully you're following along with that and you're able to practice some. I do want to show you this for some additional problems if you want to do them. So these are one of our puzzle times. And you can pause the video to do some of these and see if you get them right. See if you can find the answer over here in the answer column. You know, you don't have to do them all, but just try to practice it a little bit. Okay, your assignment for chapter 7.2. You can either do your textbook, page 305, numbers 6 through 9, so 6, 7, 8, 9, and then 18 through 25. Show me your work on that. Send me a picture of it to banksa@wbsdweb.com so you can get credit for it. Make sure to show your fence and that you're doing the opposite operation on each side of the fence in order to solve it. If you don't want to do the textbook assignment there, you can go ahead and do bigideasmath.com. You'll see there's a chapter 7.2 assignment in there, and you can check your answers twice. That will go directly to me, so you don't have to worry about anything with that. It'll already be submitted. Okay, so either one of those, good luck. Email me if you have any questions at all.